Hi Anne. Hey everyone. So I'm just waiting for the stream to synchronize and yep, so I can confirm that this is working. Cool, I can see it. So I'm trying to finish off the garbage collector and I've got a couple of hours now to me to try and do this. Then I'll go do some housework for a bit and I might come back in the evening, but we'll see. Anyway, we got to the point, so we were almost at the stage where we started to write the sweeping code. In fact, we did write some sweeping code. I'll show it here. No? Is this the wrong? That's better. So here's the sweeping code so far. We were doing that this morning, and I found a couple of bugs in other parts of the collector, so I fixed those up, and so we're just getting started here. Oh, I'm not so familiar with Richard O'Keefe's book, so Breadth First Search in Prologue. That sounds interesting. So Annie is reading some of Richard O'Keefe's work, it sounds like. Yeah, Richard has a lot of credibility, so I'm sure it is really good. So I had some emails with him because he was presenting at a conference, and I emailed him, "Hey, I won't be able to make it to the conference. Can you tell me a little bit more than the abstract?" And he obliged, and we had quite a good exchange for a few emails. So. Okay, so I'm just remembering where I got to. First use, I'm not listening to anything, so why do I even need to wear headphones? Just have it. So a lot of people have music on their streams, but I suppose this way you can put on music you like. And I'm not tempted to sing. Okay. So, is that what I want? So I'm about to add each thing to the free list. Yes, that's correct. So clear the mark and allocated bits. The mark bit will already be clear. We will clear the allocated bit there. And next, and make sure that we advance to the next cell. Yeah, and we were happy. I think that seems good. Now we've got a free list that we can use. So let's see. Oh, right, 4th of July. Yeah, I've seen a few messages from people saying that their animals have been afraid of America today. Sorry, I mean fireworks. Afraid of fireworks. Did I slip up? Yeah. Yeah, so I'm sure underscore's not the only scaredy cat. Yeah, there was That was a thinly veiled sarcasm. Okay. So, I'm actually curious to step through this in the debugger and see if it's actually doing what I want it to do. You know what? What's even better than that is tracing. So let's just have some printfs just to make sure that this is doing what I hope it's doing. That ought to be enough just to make sure that this is doing something interesting. Make. Right, so why is it still... Because cell size is undeclared. I think I'm doing JavaScript. Cell size. Now we remember the size is stored in the penultimate, in the previous place in the heap. So the word before the current pointer. So uint pointer t. So first we'll cast the current cell to a pointer t, and then dereference that to read the size. And we can use it there. And what do we get next? There's a problem with is marked. One. It only considers a single pointer. Considering heap base address while heap is less than the wilderness size. I will use the debugger here. I'm on line 174. The base address is where the heap begins. I've got the heap size pointed to the bitmap. The wilderness pointer, which I want to check, is higher than the base address. 7 FFF EC 7 EC 800 7 EC 7 yeah. Yep, that's higher. Free listing stuff don't matter. Cool. Well, it's not the 4th of July here. We've already moved past that. Today is the 5th of July. So, but I understand it's the evening of the 4th at the moment in the States. Okay, so that all seemed right. Next, I want to see what cell size makes sense. Cell size does not make sense. Okay, what happened to this +1? Oh no, it's there. So why would cell size be set to 600? Did I actually allocate something that big? Big. PZDC. I don't think so. Start the program again. So we try to allocate print size and words 2. So why would 2 become 600? Cell is wilderness pointer. You know what, I might refactor this anyway, because that's not exactly clear what's happening. Yep, so the base address and the wilderness pointer should currently be the same value. The wilderness pointer is not, it is higher. Oh, I see. Run the program again, but actually step into this function. And yeah, print heap. So yeah, wilderness pointer and the base address are the same. Next, cell, print wilderness pointer. Print heap, sorry, to see the wilderness pointer. It has become 18. Does that make sense? Yes, it does. Not 18. It's 18 in hexadecimal. Not 18 in hexa. You know what I mean. 1/8, which is not the same as 18. Okay. Cell gets the correct size, good. And we mark that as allocated. So that should all be fine. That allocation code looks correct. So what is try the record and replay debugger. Now I can go backwards. Break. I probably didn't need this. All I needed was a watch point and a step forwards. But we'll see. So now I have a watch point. I can see that I've assigned 2 to that, as I should have, for the size in words. Disable the first breakpoint, continue, and it never gets reassigned. So when it's considering that, that's... Why would it consider that address? How did it even get that? Because that's not in the heap. Run, continue. Okay, now we're at collect. Let's see, do these addresses make sense? The base address is no longer the same as it was. How did the base address get updated? And also the wilderness address. They've... Okay. So break. Let's go back to breaking it try allocate. Run the program again. Oh, continue print heap. Okay. Okay. So, where's the problem? We were... Okay. The base address of the heap is... I'm just going to check whether something is going to show up on the stream. If I highlight things to point them out... Yes, okay, that'll... When I click something with the mouse, and even the mouse pointer, good. Because I'm capturing the window with a different method now. I'm not sure if it was going to work. And if I didn't say already, I apologise for all the hammering and noises outside. There are construction sites either side of my house right now. So, and since I'm doing this in the daytime, they're busy. So, they're putting up lots of new houses in this area. Okay. Yeah, so the base address has this value at this point. And the wilderness pointer has the same value, which is good because we haven't allocated anything because this is the first time try allocate got called. Enable. Okay, so let's continue until we're collecting. Now that we're collecting, what are those values like? The base address is the same. Good. The wilderness pointer has moved. Good. Now, now I need to next. It's going to do all the tagging, the marking. I want to continue to here. 172. Break pzgc run c pzgc.c 172. Continue. Yeah. So it's here. It should get yep, that looks correct. So we're going to consider the right cell. Next, cell size, print cell size is 600. Oh. Yeah, because in one thing I'm doing, it's an off by one error. So what I should actually do is abstract this away with a function and then only write it once. See, I've got other situations where I fill in the cell size and then I move the pointer along, which I don't like. That's not my favorite style. And here I've got I'm dereferencing it, but I'm not moving the pointer along first. So instead, what I will do is I will do cell get size. Static size t. Let's go with that. I can fix up types later. Cell get size. And return p cell cast to uint pointer star t star +1, no, -1 to move it backwards, and then dereference that. Could probably use array subscript for the same thing. It might look tidier. Do we think so? Maybe. Yeah, let's do that. So right size 25. I'm gonna call it set. going to be really tricky. Probably yet again breaking some C coding rules, but this is what's happening. So now I can call cell size, and I can either I can dereference it and then assign to it, or read from it, or whatever I like, but with only one function which computes the offsets. Cool, and I'm happy. So now, where are we considering cells? That's setting up the heap. It's freeing the heap. Try allocate. So cell should be the wilderness pointer. Just define that as, yeah, I don't know. Kind of feel like that should be a double pointer. Good. No, we got this. So, now cell no longer needs this awkward increment. Cell is pointing at our memory. And instead we use cell size as a function, dereference it and assign to that to set the cell size. Size bytes of memory. The allocated bit is set for the memory word corresponding to cell. The word. Let's update this comment. All those builders love hammering stuff next door. It's bang, bang, bang. So I'm just looking for other places where I've used the cell size, where now I can use that new function I made here. Use it there. Cell is cell size, cell p cell. Dereference that. That should be it. Now there's a lot of sanity checks I could be adding. I feel like I want to get the basics running first, even though those could probably help. Implicit directly. Okay, here we go. Cell size is there, but here it was still cell get size. So make that cell size. Fix that up. That's fine. That's fine. Okay, build again. Yep. Okay. Okay, so it considers all the things and then fails because it's marked doesn't work. So why does our sweeping code attempt to run that? Like, it should have exited the loop. Because the wilderness pointer itself it goes out of bounds when we run out of memory. What we want to do is compute the base address plus the heap size, which is you know what, the amount of times I cast something to a double pointer, I might as well do it now. Well, I'll get this working, then I'll do that as a refactoring. I don't want to break more stuff. Yeah, base address plus heap size. What is heap size even measured in? Because I've forgotten. I'm suggesting it's in bytes. Yeah, it's in bytes. Which means I need to do that. Considering assertion is valid object. Okay. So we're having some kind of issue with that limit at the end of the heap, which is likely because we put that cell size in the word before each item. Okay, it's likely because it's not an allocated item. Yes, which is fine if we're at the end of the heap and we couldn't allocate to it. That makes sense. So what's happening is that we're failing to allocate the item that straddles the end of the heap, the boundary at the end of the heap. But when we're sweeping, we do consider it valid because at that point we don't know its size. So its size hadn't been set because it was never allocated. So what we need to do, we just need to loosen this assertion. Is valid object and is valid address, which would be a weaker form of is valid object with only that first part. So we will call it is heap address. Now, all we need to do is add the declaration. Why would it free that one? Because it's not marked. Duh. But needs to be allocated for that. Is marked. You know what, it is below the wilderness pointer. So I can kind of grant it that as a rule. It's only that the size is 0. We hope. I want to refactor as marked as well, so that I can use any of the things in the bitmap a bit more modularly. same as I've done with cell size. But do I want to do that now? Or should I let it be for a little bit? You'll also notice it's considering a lot of pointers and considering whether they should be free, but not actually freeing them. That's because it's finding, although those objects are garbage in my sense, because I understand the program, it's actually finding their pointers on the stack, because Plasma's still pretty dumb with how it manages the stack. So it's finding their pointers and thinks that they're live, when if Plasma had tail recursion, they would be dead. So there's a couple of things we want to do. I want to refactor that access to the marked and allocated bits. I want to use an allocated test before I add that last item to the free list, or maybe test its size. So in sweep, we get to the point where something's marked or not marked, and therefore should be on the free list. Now, it shouldn't matter whether it was allocated before or not, because we're actually going to rebuild the entire free list at this point. So, but it does matter if its size makes sense. So, if now, before we dereference it and read its size, we should assert is valid is heap address. Heap p, because we're about to dereference it. Next, we check when we consider it, we say if its cell size is not 0 and it has not been marked. Yeah, I suppose that's right. And it has not been marked, then we can add it to the free list. Otherwise, what I want to do here is the only time this should happen is right at the end of the heap. But I won't know if I'm at the end of the heap without valid size information. We don't have valid size information because we're at the end of the heap. So, otherwise, what I actually want to do is this. So, if the cell size information is valid and we're marked, then do that. Otherwise, break the loop. Because we're almost certainly at the end of the heap. If we're not at the end of the heap then there's a bug. So now this loop will actually never exit because of the condition here anymore. Oh, unless there's some kind of off by one error and we just happen to move the wilderness pointer just beyond, just into the end of the heap. Okay. Make test out of memory. Good. Did anything get freed? Our garbage collector failed to free any memory at all. So, yeah. What we need to do, now's a good point to commit. We'll do some refactoring after. So what we can do in order to make this test actually find free memory is do the allocate lots loop as a set of nested loops. Allocate lots 1 and allocate lots 2. Allocate lots 2 is basically the same as it always was. Allocate lots 1 calls allocate lots 2, but it calls allocate lots 2 starting with, let's say, 32. So 32 iterations of allocate lots 2, creating garbage, leaving it around, and then returning. That's important. So when this recursion ends, and all the frames from allocate lots 2 are removed from the stack, then the pointers in those frames will no longer be marked as being live, and we'll be able to free them at that point. Now, allocate lots 1, I'm going to run it for, how many iterations should it have? I'm going to run it for 128. Is this enough to actually trigger the collection? Might not be. Oh no, 128 by 32, because that's multiplication. Fairly sure that'll... What was it set to? 300. Yeah. Should be good. So, make that, make, and call the right function. It did not trigger the garbage collector. Yes, setting values after. Well, there's... I don't know, I'd probably be checking a bit better if I wasn't live streaming. What I'm finding with the live streaming in particular is that a lot of it's in my... I can only concentrate in my mind on talking or coding, and I'm having to split that a bit. So I'm not considering things as much as I perhaps should be. Oh, I see why. Not because of the numbers, because that did make sense to me. But because I was missing a recursive call here. So if I'm actually going to have nested loops, I need to make the outer one an actual loop. Oh, yes, it's no, I get it. It's hard to watch streams and actually get work done. So I'll catch you later, Annie. It was good to have you on. So it's yeah, my plans for tomorrow changed, and so it wouldn't have been. It would have only just fitted in if I was going to stream in the morning, but it was going to be risky for other plans. So cool. Considering some memory, freeing some of it, keeping some other memory, and still running out of memory because we're not using the free list in the allocator yet. But that is good. We also need to prove that we're tracing through the heap values properly. So it'd be kind of nice if I wrote a tree insertion thingy and tested that. But this is good. So we're on track. Cool. So now, when we have try allocate, first we try the free lists. And because I'm lazy, I'm going to find the first cell that fits. No, I can do better. Cell is heap free list. Actually, I kind of want a previous pointer. If prev is not null, then cell is you know what, I want this to be ternary because I don't actually need to do any actions and it's going to be fairly succinct. If prev is null, then null, else prev. Should actually be the next pointer, which is stored right in there. So now we begin the loop. While cell do something if cell is null, then if prev. So if we got to the list, got to the end of the list, well, we know that cell will be null when we get here. So if prev is not null, so there were things in the list. Because what we're going to do is find the best so far. If there was a best, then the best is our cell. Can I just do that? No, I need to mark it as allocated and do all that stuff. Sorry, just stuffing about with things. Not that one. That one. Good. So while cell is not null, no. No, I did want the other pointer. I wasn't thinking. Or did I? No, bugger that. I mean, pardon me. Yeah, I do need another pointer here. So void best yeah. So best is null. And So, if cell is not, well, while cell is not null means that cell will be not null. If cell size of cell is greater than size in words, then we can consider this cell. However, if it is better, if there is no current best, then cell is best. I mean, best is the current cell. And we continue. Else, oh sorry, if best is, if there is no current best. Otherwise, if cell, so now we want to find the smaller of the two cells. So cell size cell is less than cell size best, then this is the more appropriate cell for this allocation. But we keep searching because our list isn't sorted. If we get to the end of the list, there is a best, then we allocate it and return. If there is not, then we allocate from wilderness. And if we never find a cell big enough, then what happens? Yeah, we keep failing. We keep... If best is not null, and... Oh no, we've already checked that the cell is appropriate. Yeah, good. That's fine. Yep, so tags. Confuses me when my tags file's not up to date. And run. Oh, look at that. What has happened? What kind of infinite loop do I have there? See, I mean, I could debug it. It's always easy to fire up the debugger or add printfs and things like that, but it's also great just to stare at it for a while, because either it's more rewarding, or I don't know what. Sometimes it's just easier. Sometimes you just realize it when you look at it more critically. So, in case you missed it in that case, I forgot to advance to the next items in the list in that search. So, I did rebuild, run. Great. It's probably a memory error, so let's use Valgrind. There we are. Try allocate on line 1 for 1. Free list was never initialized. And set wilderness. I'm also going to move these initialization so that they follow the same order that they appear in the type declaration. So base address followed by heap size followed by the bitmap, wilderness pointer, free list, and stack. Interesting that it still ran out of memory. So my best guess is that it's just not finding the new memory off the free list. So let's see what break. I want 2 breakpoints, one at collect, and I'm going to run until I find that one. Or run. Then disable that one and create a breakpoint on try allocate. Then continue until I get there. Now I've done the collection. There should be memory on the free list, but let's find out. Next. Let's just take a look. Free list, yeah, it's got a value. So while cell is not null, cell size and size in words. That's funny. Oh! It doesn't need to be bigger than the amount of memory we need. It only needs to be bigger than or equal to. Different error. What would also be good is a little bit of diagnostics to ask it how much memory was freed. And of course how long it took. I mean, I keep saying that we don't care about performance yet, but it's nice to be curious. So at least have an idea so that when you do care, you know exactly how much to care. Okay. Invalid read of size 8 in try allocate. No, it's dereferenced something interesting there. 144. So cell has bogus memory in it here. But at how many iterations? GDB syntax wasn't so awful, I would just ask it to trace how many times things got called, which is the normal way to do stuff. But it is fairly awful, and so printf is just as good. Okay, so it's the second time it tries to allocate after collection. Interesting. The first one goes all through the loop. Huh, you know what? After it's finding the free memory, it's not removing it from the yeah, that's the problem. Okay. So it's looking through the free list to find memory that it can use. But once it finds it, it's not doing anything to remove it from the list, the linked list, which is exactly what it should be doing. So we need another pointer to track the one previous to the best one, and use that to remove it, to unlink it from the list. Oh, and the one next to the best one. No, we don't need that. Anyway. Because, yeah, what's happening is we're taking this memory from the free list in the first time, which all works fine, but not removing it from the list, then writing into it because it's our memory, because it got allocated. And as we do so, it's corrupting the free list, which is why we then hit an error. So I've got best and previous best. Oh. Here we need to update previous best to be best. Well, best is known to be null. Previous best was always null, now it's still null. Here's where we need to... I mean, I was going to do it in both, but it's redundant there. It wouldn't actually... It's already got that value. Good. So previous best is previous. Now we need to unlink it. If previous best is null, then we're at the big... Oh. No, that's not how this works. We do need another pointer. So we need previous cell as well, because what we're looking at here yeah, that's right. So each time we advance the list, we need to write previous cell is cell so that we can track the previous one in the order that they're stored in the list. While previous best, it tracks the previous version. Each time we assign cell to best, we also need to assign previous best to previous cell. Because that's how we unlink it. Then, if previous cell is is null, then we know that we're at the beginning of the list, and the thing we actually need to do to unlink it is to set heap free list is equal to previous next. No, best next. Because we can expect that heap free list currently points to best. Otherwise, we need to set previous best's next pointer to the best next, which will unlink previous from the list. Ah, silly me. Next is just a matter of dereferencing them. Because that's how the list is stored. You know what? There's another thing that we're forgetting. And that's we can't have empty allocations. Because, well, I'm sure a bunch of off by one errors and things would happen, but also we'd have no room for the lists linking in the free the linking pointers in the free list. Also, there'd be a problem. There'd be no sense in allocating zero memory. No, a segmentation fault. Must have auto-completed that incorrectly. It ran a lot longer and then failed to allocate memory. So that's interesting. So it could be that we just are not giving it enough memory now and that the collector's actually working. So let's see. As you can tell, I'm sitting up straighter, I'm getting excited. We could have something now. keep that. And keep that. Okay, so there's just 2 printfs. Now what I want to do is when we collect, mark so many root pointers, and I also want to record how many things we mark in general. So this will give us an idea about whether we're reclaiming enough memory yet. Oh, cool. Chit chat in the conversation. Hey, so I'm working on a new programming language, and I'm actually at the moment writing the garbage collector for it. So I'm about to finish working on the garbage collector. So it's a mark sweep collector. I'll bring up the notes if you like. Things are a little bit easier. So my task is to write the simplest garbage collector you can possibly make. That all it has to do is reclaim memory. It doesn't actually have to perform well. I can do that. I can improve that later. So, and even replace it later. So it's a mark sweep, non-moving conservative collector. Non-moving means it can't do generational GC or semi-space copying or anything like that. So mark sweep, it stops the world, does all the marking and all the sweeping. How long did it take me to learn everything I know? It took I've been programming since I was about 12. I'm now 34. So, yeah, so 22 years. Yeah. And, yeah, it took me about 22 years. Quite a bit of study and practice as well. So, and my thing is programming language implementation and programming languages themselves. So that's what floats my boat. Yeah, so it's a it's a conservative collector, meaning that when it finds something, a value that might be a pointer, it has to assume that it is a pointer. Because it doesn't have, I haven't added any kind of type information for it. Which means that it has to be non-moving. I eventually do want to make it an accurate moving collector, but that's a different project. That's later on. It has to support interior pointers, which means that pointers aren't just to the beginning of their objects. They can go up to 7 bytes into an object to be considered valid, and to hold that object live. And other than that, it's just supposed to be really naive. I changed my mind on this feature. So we're no longer storing cell sizes are inline. Cell sizes are inline. Mark bits are not. Allocated bits are also used and outlined. So that we can test if a pointer points to a real cell. So, what we do next. Where was I? That's right, I was adding printf statements so that I can track how much memory we're actually collecting. Number marked AM. So I need to update the declaration up here for the mark function. No, I didn't put it there. I put it here. Okay. Type long int, but has thinger unsigned int. Okay. So long we use the correct format string there. LU is type of long unsigned int, but it's just an oh, is it? Okay. Oh, so it is. Let's see if that works. Okay. That's nice. Ugh. No, it's not. Look at these results. That's totally wrong. Number it's marked, num marked. How is it getting that? That would help. Why it didn't give me a warning for that, I don't know. That's better. Oh right, yeah, that's fine, because we're not actually... This particular program doesn't actually link any items on the heap, so it's actually a really poor test. Okay. Why does it not free any memory at that last stage? Let's see what happens if we get some more diagnostics out of the sweep phase. Yep, that's what I was worried about, but it's sweeping less and less. And probably because they no longer have their allocated bits set, I suppose. Does it consider just as many? Yep, just checking 171 cells each time. But why is it not finding... Because sweep code, upon finding that something is marked, has to clear the mark bit. Well, you can always clear the mark bits afterwards. I'm going to clear the mark bits now. So that yeah, I'm going to always clear the mark bits here, but you can do it in a later stage in a more bulk operation to make it either faster or allow parallel sweeping and things like that. Good. The garbage collector works. It does not follow pointers between... I mean, it does follow pointers between objects, but that's totally untested at the moment. And the rest is a matter of tidying up. Which, it's almost 5 o'clock, so I'm going to finish up. I'll make these commits and I'll do some tidying up later on. I probably won't bother streaming it anymore today. Yeah, but yeah, that's the garbage collector fairly much concluded, at least for now. So I'll tidy some things up. It was, and if I actually need to fix any bugs or anything like that, I might stream those parts. But for now, I'm done. And when I stream again, it won't be next Monday. It'll be the Monday after that. And we may be finding a new topic, or we might be tidying this up a little bit. So, all right, cool. I'm going to roll this all into one commit anyway. Commit. Cool. Alright, well, have a good evening, everyone. thank you for joining me. Catch you later.